Hello friends, welcome to the last part. This is part 4 of C5 paper solution, mathematical physics for 3rd SEM 2021 under Dibrugarh University. Okay, so in this video this paper gonna be completed. Okay, and links of part 1, 2, 3 are given in the description box. If you haven't watched yet, please go through them. Okay, so before we start, please subscribe the channel if you are new to my channel. Also share with your friends, help me to grow my channel. Hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. Okay, so now let's start. So I have already solved question number 3 in part 2, but I forgot to record this solution of this second question of question number 3. That's why I am recording it in this video. Okay, then we're gonna solve this last question. This is the last question number 6b. Okay, so there are two options. You can solve either this one or this one. Okay, I'm gonna solve both. Okay, so stay connected. Okay, in order to solve this, we're gonna use this identity here. You see, first let me write this solution here: -1 to +1, right? P3 square x dx. Sorry, not cube. That was the square. That's supposed to be square, right? So here we're gonna use this. So we know that integration from -1 to +1 Pn is of x square dx is equal to 2 by twice n plus 1, and here our n is nothing but 3. Just replace the n by 3, then you're gonna have the answer, right? So just we're gonna replace the n by 3, -1 to +1, so p3 square of x dx, here 2 by 2 into 3 plus 1, and this is 2 by, that's gonna be 7, right? 2 3 is 6 plus 1 7. So this is our answer. That's very simple. So hope you have understood. Here is the last question number 6b. Okay, so find the solution of one-dimensional wave equation in Cartesian coordinates. Okay, let me go to the solution. Here you see this is the solution, not completed yet. One more slide is there. So here is the wave equation, one-dimensional wave equation, and this is del t. Here it is square. So hope you can recognize this, what it is written here, c square. So second order derivative of y, then x square here, del, right? So I hope you can recognize. Okay, so just let us consider the solution be, suppose y is equal to capital X and capital T, where capital X is the function of small x, this is small x, and capital T is the function of small t only, right? So then if we differentiate this with respect to t, del y by del t, then when we differentiate partially, with respect to t, then x must be considered as constant, right? Then d capital T by d small t here, right? And then again, if we differentiate this with respect to y, not y, x. Now this is x, so we are differentiating partially with respect to x. So then t should be considered as constant. Then we get here d capital X by d small x here. Okay, so hope you have understood this. So now, as these two are functions of single variable only, okay, so here you see what we can do here. You can see these two are second order derivative. Here if you see the question, these two are second order derivative, right? This is the question. This is the equation, right? C square. So this is the equation, right? So that's why we're going to differentiate this two again with respect to x and t. Okay, so first let me differentiate this with respect to t again, then we're gonna get this one, and if we differentiate this with respect to x again, then we're gonna get this one, right? So then using these two, using these two results in the given equation, in this equation, this is equation number 1, suppose in the given equation number 1, right? Then what we're gonna have, right? So let me write this. Okay, then we're gonna get this equation, right? So what we have done here, so this is capital T, second order derivative of x with respect to small x, right? So we have used these two values here and here, right? So we have got this equation, capital X, second order derivative of capital T with respect to small t, right? So hope you can see these things. Okay, so now you see, let me clean these things, just wait. So what is the next step here from here? This is 1. So if we take this as 1, then we have used these results in equation number 1, right? So now separating the variables, so what we're going to do here, we're going to keep the x on one side of the equal sign, and t is on one side of the equal sign, right? And doing so, what we're going to do, so here you see, if you simplify this, then 1 by c square t square, sorry, not t square, c and t, second order derivative of t dt square is equal to 1 by capital X, second order derivative of capital X with respect to small x. So we're gonna get this equation, or you can write the same equation in this form. Okay, so then we have considered each part equal to k. We have considered each part equal to k. See, each part equal to k. So this equation and this equation both are same, right? So they have written this one, this ct square, just below it, instead of writing this one like this. Okay, so now we have considered that each side is equal to k. This is equal to k, right? So now, so let me go to the next slide. Okay, in the next slide we're gonna take this one is equal to k. First we're gonna take this. Okay, first we're gonna take this part is equal to k. We're gonna suppose that. So then what we will get, we can take 1 by c square t, second order derivative of t with respect to small t is equal to k. We're gonna take this. So now let me copy this one and let me go to the next slide. Here you can see, so from this equation, let me go to the next slide. Here you see, if from this equation, what you can write, second order derivative of capital T with respect to small t, k into c square t, and if you bring this one to this side, then you're gonna get this equation. Here you can see this equation we're gonna obtain, right? Then similarly, if we take this part of the equation, right, okay, this is gonna implies second order derivative of capital X by with respect to small x is equal to k into x, so k into capital X, right? So if you bring this one to this side, then what you're gonna have, then you're gonna have this equation. Here you can see this equation you can have, right? So now here you see auxiliary equation is going to be equal to from this part. If you see from this equation, the first equation, what you can do here, just what we have got, second order derivative of capital T by this minus k c square capital T is equal to 0, and from here this can be written as, you can replace as d square by dt square, it can be replaced by capital D square, right, which d represents this, right, and d square represents this, sorry, this. So hope you have understood this. Then minus k c square, and this t is taken common, then t is taken common, is equal to 0. So from here, what gonna be the auxiliary equation? Our auxiliary equation will be m square minus k c square is equal to 0. So this part should be taken is equal to 0 to obtain the auxiliary equation. This is the auxiliary equation, and similarly we can do the same here as well. So here you see this can be written as d square minus k into capital X is equal to 0. We can write that way, and from this we're gonna get the auxiliary equation, right? So from this we're gonna get this auxiliary equation. Here you see m square minus k is equal to 0, and which implies this m is equal to plus minus root k, right? M square will be equal to plus k and m will be equal to plus minus root k. That's what we're going to have. And from this part, what we're going to have? We're going to have this equation implies m square is equal to kc square, and that's why m is equal to plus minus c into root k. On taking square root, we have got this. So hope you have understood this, right? For case 1, so we have got two cases. Now first let me clean these things. Okay, so now let me clean these things. So hope you have understood how to obtain these auxiliary equations. So I have written here. So now here you can see, let me clean these things, just wait. So here you see in both from the both auxiliary equations we have got real and distinct roots. Here you see in this case in the first from the solution of the first auxiliary equation, here we have got both the roots m1 equal to m1 is not equal to m2 here. Okay, both are different. M1 is equal to suppose plus c root k, and m2 is equal to minus c root k. That's what we have got. And from this equation, this is the solution of this equation. Here we have got m1 is equal to plus root over k, and m2 is equal to minus root over k. We can take that way, right? So when m is not equal to m2, so this is applicable in both cases. Here you can see that these two are not equal, roots are not equal here and here also. Okay, if these two are not equal and both are belongs to the real number, if both are belongs to real number, here you see m1 and m2 both belongs to real number, in that case the solution should be of this form: c e to the power m1 if the equation is of the function of x. If we are doing it for x, then it should be something like this: c to e to the power m2 x, right? And if it is t, then it should be t, right? That is very simple thing. So that's why, okay, we have taken here capital T and capital X here, right? So that's why here we should get t is equal to this one, which comes from this equation. This is the solution of this equation, and this one is the solution of this equation, right? So you can say just let me clean these things, let me clean up. So let me take this is equation number 2 and this is equation number 3, and solution of 2 is this and solution of 3 is this. Okay, so here we have got 3 different cases when k is greater than 0, right? In case of k is greater than 0, here you see, then these two belongs to real number. If k less than 0, we cannot say that these two real, that those two gonna be virtual. So as we don't know k is a real number, we have taken as k as a constant, but we don't know that k is greater than 0 or k is less than 0 and k is equal to 0, right? So here 3 possible cases involved. When k is greater than 0, then these two roots are real and real and unequal. So in that case, these two are the solutions of these two equations, right? As I have already told you. And if k is less than 0, then k is something, suppose -4 or something else, then it's gonna be plus is gonna be root 2, right? That's gonna be imaginary. In that case, the solution should be of this form. This is the solution of equation number 2 solution, and this is the solution of equation number 3 solution, right? So for complex roots, right? So if k is equal to 0, if suppose k equal to 0, you see, if k is equal to 0, in that case, in these two cases here, you see, your m1 m2 gonna be equal to, in the first case, for this case, that's gonna be equal to plus minus 0. That means simply 0. That means m1 equal to m2 is equal to 0. Okay, when roots are equal, then solution should be of this form: c x plus c2. Okay, so we have already used here 1 and 2, and if you are doing it for t, then it should be t. Okay, so then this is the solution of equation number 2, and this is the solution of equation number 3, right? So now these are the cases. So as we have considered that solution is y is equal to capital X into t. Okay, we have considered here y is equal to, this is the solution, y is equal to capital X into capital T. We have considered that way, right? So that's why, for these three cases, okay, case 1 and 2 and 3, we're gonna have 3 different solutions. Now you see, though we have 3 cases, and putting this t and x in this equation, that we have considered the solution like this: y is equal to capital X into capital T. If we put x and t here, and for these 3 cases, we're gonna have 3 different solutions. But in case of wave equation, okay, in case of wave equation, in this equation, okay, so this k that we have considered, the k is less than 0. Okay, we're gonna dealing with this case only. So we're gonna put these 2 results here. So then our answer should be this one. This is the required solution of the equation of this wave equation, this equation number 1. Now let us solve this. Find the solution of 2D Laplace equation in cylindrical coordinates. So here you can see, now let me go to the solution. This is the solution, this is the Laplace equation. Here you can see. So here I have considered that u is equal to capital R into capital T, where capital R is a function of small r and capital T is a function of theta. Okay, so you can get it. So now you see what we have done here. As we have second order partial differential equation, here you see is a partial derivative of u with respect to r. So we have differentiated this solution that we have considered del u by del r, and then also we have differentiated it with respect to theta as well. Okay, so differentiating with respect to theta and differentiating it with respect to r, we have got these two, right? And again we have differentiated this one, and again differentiating this with respect to theta, we have got this one, right? Now using these two results in this equation, in this above equation, so we have got this result, right? So hope you have understood this. So now what we're going to do here, you can see that clearly. Here we have taken this t common from both the terms, so this is the t here. So then this term is shifted to other side, then and we have separated the variables, right? We have separated the variables. This equation implies that r square second order derivative of capital R with respect to small r, then plus r into d capital R by d small r into t, and minus r second order derivative of capital T with respect to theta, right? That's what we can have. Now if we separate the variables, then t gonna be on the other side, that's gonna be 1 by t, right? And r is brought to this side, we have got this r and we have got this t here. So that's what we have got. We have separated t's and r, right? And we have got this equation, and we have taken each part as a constant h. Okay, we have considered each part equal to h. Now let us take this part is equal to h. Okay, if we take that, now let me go to the new slide. Here you see, so we have taken what we have taken, this one, this part as equal to h, this part, right? So what is that? We have taken that r square second order derivative of capital R with respect to small r plus smaller dr small dr, yeah, divided by capital R is equal to h. And if you simplify this, then you're gonna get this equation, right? So if you simplify this, then what you're gonna have, capital d capital R d by d small r, here capital R into h. Okay, and if you bring this to this side, then you're gonna get this equation, right? So here we're gonna put r is equal to z. Here if you cannot see, then let me write here, r is equal to e to the power z. Let us put this. So now if you put r is equal to e to the power z, then what are you gonna have? So if you take log on both sides, log r will be equal to log of e to the power z, which is going to be equal to z. Okay, log of e to the power z is going to be equal to z. So if you differentiate with respect to r, then what you will get? If you differentiate with respect to r, then you're going to have 1 by r is equal to dz by dr. That's what you're going to have, right? So now you see, so this implies that dz is equal to, or you can say 1 by dz is equal to r into 1 by dr. That's what you can write. Okay, so we can now replace this part by you see, we can write this one as d capital R by dz, right? So hope you have understood this. So what we can do here, you can say this term, if you take this term here, r capital R, this is nothing but r into 1 by dr capital D capital R. So this can be replaced by 1 by z, and if you do so, then you're gonna get d capital R by dz, right? That's what you're gonna have. So hope you have understood this. So now what we can do here, again, if you differentiate this again with respect to r, then you're gonna have, so you're gonna get this. If you differentiate it with respect to r, we know that ddx of 1 by x is nothing but minus 1 by x square, right? So according to that, it's going to be minus 1 by r square. That's what we're going to have. Then here we're going to have second order derivative of z with respect to r. That's what we're going to have. Now let me do one thing. Let me copy these things and let me go to a new slide so that I can explain better. Actually, you don't have to show all these things, but if I don't explain, you will be confused. Okay, how we have got this equation from this equation? Okay, so you must know that. So that's why I'm going to explain this one. So now let me take a new slide and let me copy these things, all these things I have done here. So I have taken a new slide, and these are the things we are dealing with. So here you see, in this case we can write d capital R by d small r as dr by dz, then again dz by dr. We can write that way. Now you see, this dz by dr is nothing but 1 by r, right? So if we use that value here, 1 by r into d capital R by dz, that's what we can have. Now if we differentiate it again, dr, second order derivative of capital R with respect to small r, then we have to differentiate this one as well, this part, right? So and then what will happen here, we're gonna apply the product rule, right? U into v rule. So in that case, derivative of the first function, that's gonna be minus 1 by r square, because we know ddx of 1 by x is minus 1 by x square, right? So that's what we have done here. So then into second function is dr by dz, and then again derivative of second function into first function. First function is 1 by r, and derivative of second function will be second order derivative of capital R with respect to z. And one more important thing, that when we have differentiated this with respect to r, here we are differentiating with respect to r, here we have dr by dz. So that's why again we have to write here d, dz by dr. That's what we have to write, okay? And dz by dr is nothing but 1 by r, so we're gonna put here 1 by r minus 1 by r square d capital R by dz plus 1 by r. So if we put here 1 by r, then we can write this 1 by r square multiplying with this, so we can write 1 by r square capital the second order derivative of capital R with respect to z. That's what we're gonna do, right? So now you see what we gonna have here. So if we multiply both sides by r square, then this term can be obtained here. Then this equation becomes something like this, minus d capital R by dz plus second order derivative of capital R with respect to z square, and that's what we're gonna have. So now we're gonna replace d by dz by by capital D, and d square by dz square, it's gonna be replaced by d square, and doing so this is gonna be equal to minus d plus d square, and r is taken common, capital R is taken common. That's how we can write, okay? Or we can write that r square d square capital R by dr square. We can write the positive term first, then the negative one, then r. We can do this one. So we can replace this by this value, and what we can do, we can replace this one by, now you see. So let me clean all these things, okay, as we have already obtained. So hope you have understood. You don't have to show all these things, right? Just in order to explain you better, I have shown this one, okay, so that you understand. And from here you see 1 by dz is equal to r into 1 by dr you have got. So here you can see that dr by dz, that's gonna be equal to r dr by d smaller. That's what we will get. So that's why in this equation this term can be replaced by this value, right? Dr by dz, which can be written as, if you replace the dz by capital D, then we can write this one as r capital dr as dr, okay? So that's why this equation becomes, by using these two values, okay, by using these two values, this equation becomes d square minus d into r, then plus dr is equal to r into h. And let me bring this r into h to this side of the equal sign, then it's going to be minus and 0. So from here we can take all we can take these r's common, then d square minus d plus d and minus h, r is taken common, equal to 0, and these two cancels, so we're gonna have d square minus h into r is equal to 0. That's what we're gonna have. So therefore our auxiliary equation will be d square minus h is equal to 0. That's gonna be the auxiliary equation. So that's what we have got here. Here you see d square minus h is equal to 0. That's how we have got. So then we have got solving this, we have got d is equal to plus minus root over h, and in that case the solution here you see m1 and m2 in this case. So let me clean these things. Okay, so no longer needed these things. Okay, so now you see, as we have got d is equal to plus minus root over h, and so that's why m1 is equal to, you can say, plus root over h, and m2 is equal to minus root over h. And in this case equation are distinct and real. If they are real, then the solution should be of this form: capital R is equal to c1 e to the power root over h into z and plus c2 e to the power minus root over h into z. Now you see, as this can be written as e to the power z whole to the power root h, and e to the power z is nothing but r, so we can write r to the power h. And similarly this can be written as r to the power minus h, and then we're gonna get this solution. Here you see, this is what. So now let me clean this 6. So this is here. Let me write here. If you can't recognize, then this is the answer, right? H square plus c2 r to the power minus root over h. That's what we're going to have. Now let us take the other part of this equation. Here you see, let me go to previous slide. Just let me clean these things. So here you see, now we're going to take this part. So minus 1 by capital T, second order derivative of capital T by with respect to theta is equal to h. If you simplify this, then what you're going to have? So let me write here on this side, just here. Okay, then what you're going to have? Then you're going to have this, right? Minus you can say ht, and if you bring it to this side, then it's going to be positive. So let me write here ht is equal to 0. Now let us solve this equation. Here is the equation we have got. Again here we're going to replace this d by d theta by capital D, and for second order derivative there will be d square, and doing so we have got this. And so auxiliary equation is this, and here you see, if this is the auxiliary equation, d square plus h is equal to 0 is the auxiliary equation, then d square must be equal to minus h, and if you take square root, then that's going to be root over minus h, and which is nothing but I square into h. You can say root over I square into h. I square is minus 1, so and h root I root h, and there should be a plus minus as you are taking square root, so there should be a plus minus, right? D plus minus d is equal to plus minus root over this. Okay, plus minus. So one root is m1 is positive I root over h. Here we are getting imaginary roots, minus I root over h. So if these are the roots, if you compare this root with alpha plus I beta, and this one with alpha minus I beta, right, then the solution should be something like this. Already we have used T1, C1 and C2, so we can write C3 cos beta into theta plus C4 sine beta into theta. That's what we're going to have. So here beta is, in this case, is root over h. Root over h is the beta, and alpha is 0 here. You can say 0. Okay, so that's how we have got this solution. Now let me clean all these things, right? So you can see the solution clearly. So hope you have understood this. So these are different cases, okay, for which you're gonna have different solutions. Okay, so now for 3 different cases we have got 3 possible solutions here, right? So hope you have understood this, right? So when you have taken h is equal to minus p square, then your solution should be of this form, right? So here, if you cannot see this part, let me write here c11 e to the power p into theta plus c12 e to the power minus p theta, this part within bracket. So hope you have understood this. Okay, so now you see, if you put h is equal to 0, then our answer should be like this. Okay, and if you put h is equal to k square, the answer should be of this form. Okay, so anyway, just we are not going to discuss these things, but we can end here. Okay, so here you see we have got this solution for r and t, and if you put here u is equal to, we have considered r, which is a function of small r, and into capital T, which is a function of theta. So we have, if you put the value of r and capital R and capital T, these two value here in this, then you can get this solution. This is the solution. So thank you for watching. See you in the next video. In the next video we're going to solve 2023 paper of the same subject. So stay connected. So thank you. See you in the next video.